Have you ever heard of the plan to nuke the moon? No, this isn't a sci-fi movie plot. In the late 1950s, during the peak of the Cold War, the United States government seriously studied a top-secret plan to detonate a nuclear device on the lunar surface. It was a real project, with a code name, a team of scientists, and a whole lot of math. This is the story of Project A119, why it was ever considered, how it was supposed to work, who was involved, and ultimately, why humanity's first major act on the moon wasn't a mushroom cloud. It all started with a beep. In 1957, the Soviet Union launched Sputnik 1. A small beeping metal sphere orbited the Earth, and with every pass, it sent a wave of shock and embarrassment through Washington. The message was clear. We beat you to space. At the time, the space race wasn't just about science. It was a high-stakes battle for prestige, political power, and psychological dominance. If you could conquer the final frontier, your ideology looked superior. American leaders were desperate for a dramatic, undeniable response to reclaim the narrative. Out of this pressure, a wild idea began to form within the U.S. Air Force. The concept was simple, yet audacious. Launch a rocket carrying a small nuclear warhead to the moon and detonate it. The goal wasn't to start an interstellar war or to weaponize the moon. It was a PR stunt, a demonstration of force and precision. The explosion would create a brilliant flash of light, bright enough to be seen with the naked eye from Earth. It would be a powerful, unmistakable signal to the entire world saying, "Look, we can reach the moon, and we can do it with pinpoint accuracy." But there was also a scientific angle. A nuclear blast would kick up a massive cloud of lunar dust and rock. By observing this plume from Earth, scientists could analyze the light it reflected and learn what the moon's surface was actually made of. Was it fine powder, coarse gravel, solid rock? This dual-purpose mission, part propaganda, part science, was officially studied under the name A Study of Lunar Research Flights, but it's better known today by its code name, Project A119. The project assembled a small but brilliant team. The study was led by physicist Leonard Reiffel at the Armour Research Foundation in Chicago, and among his assistants was a young, promising graduate student who would later become one of the most famous scientists in history, Carl Sagan. Yes, that Carl Sagan. His job wasn't to push the big red button, but to help calculate how the explosion's dust cloud would expand and how visible the resulting flash would be from Earth. It's a fascinating bit of trivia that the man who would later champion the peaceful exploration of the cosmos began his career doing math for a plan to nuke the moon. Now let's clear up a common myth. Project A119 was never about creating a doomsday weapon or blowing up the moon. The plan was a short-lived concept study that explored feasibility, visibility, and scientific potential. It never got beyond the theoretical stage and was never approved as an actual mission. So, why a nuclear device? Why not just a massive bundle of dynamite or some cosmic fireworks? The answer lies in the vacuum of space. Here on Earth, an explosion creates a massive shockwave and a fireball because it rapidly heats the surrounding air. In space, there's no air. A conventional explosion would be surprisingly underwhelming. But a nuclear detonation is different. It releases an immense amount of energy as pure light and radiation, creating an incredibly intense flash, even without an atmosphere. This flash, timed perfectly against the dark portion of the moon, would be visible from Earth. The goal wasn't to carve a giant crater, but to create a momentary artificial star on the lunar surface. Here's how it would have worked. Picture the crescent moon in the night sky. There's a sunlit side and a dark side, separated by a line called the terminator. The plan was to detonate the device just on the dark side, right next to this line. The initial flash would be blindingly obvious against the blackness. Immediately after, the plume of dust and debris kicked up by the blast would rise high enough to catch the sunlight, causing it to glow for a few moments like a ghostly comet tail. Astronomers on Earth could then measure its brightness, its shape, and how it dispersed. It's like tapping a pile of chalk dust with a flashlight in a dark room. You hit the dust right at the edge of the light beam, and you see all the particles illuminate. That was the idea, just on a cosmic scale. But the plan was fraught with problems, the biggest being hardware. This was 1958. Rocket science was in its infancy, and guidance systems were crude and notoriously unreliable. Hitting a specific tiny spot on the moon, a moving target 250,000 miles away, was an incredible challenge. If the missile missed its target by even a few miles and detonated on the sunlit side, the flash would be washed out and invisible from Earth. If it missed the moon entirely and went into orbit around the sun, it would be a complete failure. A grand gesture meant to project strength could easily become an embarrassing flop, revealing American rocketry as clumsy and ineffective. Then there were the ethical and safety questions. What about nuclear fallout? While there's no atmosphere on the moon to carry radioactive particles across continents, the detonation would have permanently contaminated a portion of the lunar surface with radioactive isotopes. This would complicate future scientific missions, including the eventual Apollo landings. More importantly, what kind of message would it send? Did America really want its first significant mark on the moon to be a nuclear scar? Many scientists and officials worried that it would be seen as a reckless and aggressive act, setting a terrifying precedent for the militarization of space. Let's bust another myth. The U.S. was not trying to blow the moon to pieces. The nuclear devices being considered were relatively small, in the kiloton range, similar to the Hiroshima bomb, not the city-destroying hydrogen bombs of popular imagination. The moon, a massive ball of rock, would have barely registered the impact. The goal was visibility and measurement, not destruction. While politicians were focused on the global headlines and the prestige win, the scientists involved were genuinely interested in the data. The shape and speed of the dust plume could have revealed clues about the moon's surface gravity and the texture of its soil. But as the project study continued, the risks and downsides began to outweigh the potential rewards. If the rocket failed on launch, it could crash back to Earth, scattering radioactive material. Even if it succeeded, the international backlash could be severe. Allies, the United Nations, and the scientific community might condemn the act as a dangerous stunt. Ultimately, Project A119 faded away for a simple reason. Better ideas came along. The technology of robotic space probes was advancing rapidly. These probes could send back detailed, close-up photographs, land softly, and analyze the soil directly, all without the political and environmental fallout of a nuclear explosion. And then, President Kennedy announced the ultimate prestige goal: landing a man on the moon. Boots on the ground, an American flag, and rocks brought back to Earth. That was a statement no one could misinterpret. Compared to the grandeur of the Apollo program, a one-time flash on the moon suddenly seemed small, risky, and primitive. The final nail in the coffin was legal. In 1967, the Outer Space Treaty was signed by the United States, the Soviet Union, and other nations. It explicitly banned placing or using nuclear weapons in outer space, including on celestial bodies. This international agreement officially locked the door on any ideas like Project A119. The story itself remained classified for decades. It only came to light in the 1990s through interviews with Leonard Reiffel and the discovery of documents related to Carl Sagan's early career. These papers revealed the scientific questions the team was tackling. How bright would the flash be? What could the dust tell us? They provide a fascinating snapshot of a tense and uncertain time, when showing off military muscle felt just as urgent as scientific discovery. So, would it have worked? The physics suggests that yes, a nuclear flash on the moon's terminator would likely have been visible from Earth. But the mission's success depended on a fragile chain of events: a perfect launch, flawless navigation, and precise timing. A single error would have ruined the entire spectacle. Project A119 represents a critical crossroads in the history of space exploration. The choice between spectacle and science. The United States could have chosen the quick, loud flash. Instead, it chose the path of careful, methodical exploration, sending orbiters, landers, and eventually, human beings. The world learned infinitely more from the quiet data sent back by the surveyor probes and the samples returned by Apollo astronauts than it ever would have from one bright pop. In the end, the moon didn't need a blast to capture our imagination. Its silent, cratered landscape, revealed through photographs and human eyes, told a far more powerful and beautiful story. It taught us that the most profound message isn't, "Look what we can destroy," but rather, "Look what we can discover together." If you enjoy diving into declassified Cold War secrets like this one, make sure to subscribe and hit that notification bell. We have plenty more stories from the Cold File Room to share. Thanks for watching.